Hello, geometry. Alright, I had to restart the video a little bit because we were having a bunch of pages going on. So we're going to kick into polynomials today. I dated my lecture 213. This is all chapter 8 stuff. So let's start with the definition of monomial. Monomial is a real number, a variable, or the product of any combination of those. So some examples of those would be the number 18. That's called a monomial. There's one, mono, one. A variable by itself, I could have z. I could have a product of a monomial and a variable. Here's another one. It doesn't have to be a whole number. It just has to be a real number. We could also have something like a over 3. Because a rational number is a real number. It just happens to be a fraction. So those are all monomials. The degree of a monomial is the sum of its variables, if it has more. If I have 0, that means no degree. So there's none, does not exist. If I have just a regular number like 3, that implies that you have 3x to the 0 because it's the sum. Well, x to the 0, this just becomes, what's my sum of my variables? That's 0. So this equals 0. So they get a little tricky, but we'll pay attention to this. So let's do some examples. Degree of 5x is the sum of its variables. Well, I only have one variable, and its degree is 1. What about the degree of 6x to the third y squared? It's the degree of the sum of the variables added up, so this would be the degree 5. And like we said, if it's just a monomial that is a real number constant, it is degree 0. Okay. So you need to pause the video, try those next 4 real quick, and then press play, and you will be good to go. Okay, I'm not sure if Mr. Gallagher was having you pause video. So when I do video lectures, you will have, wherever it says you try, you will pause the video, you will try them, then you will push play and check your answers. If you did not get your answers right, you want to pause the video again and work through them to see if you can figure out what went wrong. Alright, let's take a look at adding and subtracting monomials. You guys have been doing these forever now. All it is combining like terms. And remember, like terms means exactly alike. When I have variables and I'm adding or subtracting, the variable combinations have to be identical. So the first thing I look at is the variable and its power. X squared and x squared exactly match, so I add their coefficients. 8x squared. If I go over here, I have x to the third y and I have x to the third y. They match identically, so I am going to add or subtract their coefficients. 4 minus 1 is 3x cubed y to the first. You're looking for like terms when you're adding and subtracting monomials. So I have an x squared, but that is not an x squared. So I cannot combine those terms. These are already simplified as much as you can. So that becomes a polynomial, specifically a binomial. Okay, so you should pause the video and then you should come back and check your answers after you try the next few. Alright, you should have gotten 8x squared. Oops, that's not right. You should have gotten 5x to the fourth and 3x squared y squared plus 2x squared y to the third, because they do not match exactly. I cannot combine them. And negative 5x squared y to the fourth. If you did not get those correct, pause the video, go back and see if you can figure out where your mistake went. Alright, let's take a look. What we're trying to get at is that these individual terms can be combined. So essential and stunning is you can use monomials, mono meaning one, to form polynomials. So poly means more than one, multiple. Mono means one. So we're just going to combine with terms so that we can build and build and build and get more complicated. So we want to take a look at what a polynomial is. It is a monomial or a sum slash difference, meaning I'm adding or subtracting of monomials. So if we looked up above here, this is a polynomial because this is a monomial being added to another monomial. This is a polynomial because I have a monomial, the difference of, with this other monomial. The rules for their degrees are different. So when you're looking at the degree of polys, it is the highest or biggest exponent anywhere in the polynomial. So if I'm looking up here, the biggest exponent I have is 2, so the degree of this polynomial would be 2. This is a monomial, but the definition of a polynomial is a monomial or one that's added or subtracted. So this power, though, is a monomial. Its degree would be 4, 5, 6. This is a polynomial. Its highest degree would be 3. Okay? So let's try some down here. You can name or identify polynomials based on their degree and the number of terms. So if we take a look at this polynomial, which we know is a monomial, it has a whole number, constant term, so its degree is 0. Its name is constant. The number of terms is 1, because there's nothing being added or subtracted to it, and it's called a monomial. This one is a polynomial, because I have a monomial adding to another monomial. I have a polynomial. Its degree is the variable with the highest value, so it is 1. Since it's 1 to the first degree, it is linear. It has 1, 2 terms, and so it's called a binomial. What's M? Binomial. This one is a polynomial. The highest degree, that's a 1, that's a 2, is 2. So it is a quadratic. We're going to learn about the quadratic function later this year. We have 1, 2, 3 terms. So it's called a trinomial, like a tricycle has 3 wheels. And our last one down here, we want to look and see if there's anything to combine. There isn't, so we're good there. My highest degree in a polynomial is x to the 4th, so it's 4. Oops, I skipped one. We'll go back and get that one. It is 4th degree. Once you get past 3rd degree, there is no special names for most of these. So we call it 4th degree. It has 1, 2, 3 terms, so it's a trinomial. Okay, I missed this one. This is 1 term, so it's going to be a monomial, but its degree is 3. Anything to the 3rd is a cubic. 1 term means monomial. So we'll get used to the vocabulary. We'll get you there. Okay, so let's take a look at some. One last definition before we can move on, and that is standard form. You probably saw this in algebra, pre-algebra. Standard form is the degree, oops, I don't know how to spell, the degrees of the monomial terms decrease left to right. Meaning we put all the higher ones in the front by their degrees and then go down from there. So this wants to write in standard form, and then we want to name it. So practicing whether it's monomial, binomial, trinomial, and the degree. So first we need to get this in standard form. It's the power of 1 here. This is the power of 0. So we need to have negative 2x plus 5. The sign in front of it needs to go with it. And this is a positive 5, so plus 5. So we have a degree of 1, and we have 2 terms. So we are going to name it, a degree 1 is anything to the first degree is linear. It has 2 terms like a bicycle, so it's binomial. Let's take a look at this one. We need to first make sure we're combining like terms and then putting it in standard form. So I have an x to the 4th and an x to the 4th. So I need to combine those to get 2x to the 4th. Next highest is squared plus 2x squared and then minus 4. So I've simplified it and put it in standard form. Then I just have to figure out what's going on. My highest degree is 4, so it's 4th degree. 1, 2, 3 terms is like a 3-wheeled bike called a trinomial. Let's do this one. Yeah, so I'm looking through and I'm trying to find the highest term. Here's one. There's an x to the 3rd. Are there any other x to the 3rds? Nope. So that's where it's going to start. I've handled that one. So x squared is the next highest. The negative goes with it. So minus 4x squared. That's done. Then down to 1x, I got negative 2 and a negative 3. So I get negative 5x because I got a negative 3 and a negative 2. Then I have a constant plus 5 and a plus 2, so that must be plus 7. So combine like terms and put them in lowest to highest, or highest to lowest order. So since I'm in standard form, I automatically know it's a 3rd degree, so it's cubic. 1, 2, 3, 4 terms. It has 4 terms. Well, 3 is trinomial. Anything above 3 is called a polynomial. It's just the generic term for anything above 3 terms. We have the next one, so we look and see what the highest term is. Well, that's negative 9, so negative 9x to the 4th. Then I don't have any to the 3, and I have a 6, so plus 6x squared plus 7. The highest degree is 4, so it's 4th degree. 1, 2, 3 terms, so it's a trinomial. Alright, next one. We got y to the 1, y to the 3, so that one's bigger. So I'm going to do negative y to the 3, handle that. Then I have plus 3y minus 9. So I needed to put it in standard form. The highest degree is 3, so it's a cubic. 1, 2, 3 terms, cubic trinomial. And last one. It is 7v is the only variable I have, plus 9. My variable goes a 1 hiding up here, so it's linear. Anything to the first power is a line or linear. 1, 2 terms, binomial. Alright, you should pause the video, try those next 3, come back and check your answers. Alright, that is what you should have gotten on those 3. If not, go ahead and pause the video, see if you can find your mistakes. Let me know, circle anything you have questions on, and we can talk about it in the morning. Alright, a couple of things and then we are done. Adding polynomials. So polynomial means we have multiple terms going on. So we're going to learn how to add them. There's 2 ways to do this. You can do it vertically or you can do it horizontally. Okay? We've already been doing this horizontally, where you take a look at your like terms and combine them. So I'm going to do horizontally first. I'm going to take a look at, I've got negative 12x to the 3rd. So if I have 12x to the 3rd, I'm looking for x to the 3rd over here. I don't have an x to the 3rd, so I'm just going to carry over 12x to the 3rd. I've handled that piece. Then I have x squared. I have an x squared here, and I have an x squared here. So I can combine those terms. 106 plus 14 is what? That is my 120 x squared. So I've handled that one and that one. I have a plain old x and a plain old x. I have negative and a negative. Two negatives when I'm adding stays negative, and I add the terms. So I end up with 255x. So I combined my x's together, and now I just have my constants. Positive 4477 and a positive 1545, and my calculator gives me another positive, what is that, 6022. So horizontally, that's how we've been doing them anyway. But let's take a look at vertical. This is going to come in handy later when these get way more complicated. So what you do with vertical is you take this first polynomial, and it goes on top. Negative 12x to the third plus 106x squared. What you need to do is, if I go 3, 2, 1, and then no exponent, that's good. If there's a blank and this said 4 and then 2, I would need to leave a space in between where there's a missing variable exponent. So we are copying this down below, plus 4477. Then the second polynomial gets lined up appropriately underneath. So 14x squared, well, here's an x squared, so I need to put 14x squared right underneath it. This is a plain old x, so I need to put that term right underneath it, and that's a constant, so I'm going to put it under the other constant. And then it just becomes adding like normal. You adding coefficients. You're not adding any exponents, you're not adding any variables, you're just adding the coefficients. So I carry them down, that's just plus 0, so negative 12x to the third plus 120x squared minus, they're both negative, so it stays negative, and I add them together and get 255x. And my calculator shows that that's 6,022. Either method works. It depends on which one you like better. So let's do another one together. So this is a 5x squared. I have a 3x and a 7x. So I need to do some simplifying before I start doing these. So I end up with, for this one, 5x squared. Negative 3x plus 7 is a plus 4x. Then I'm going to look over here and see if I can simplify anything on this side. Plus, oh, there's an x squared and an x squared. I should combine like terms. 9 plus 2 is 11x squared plus 7x. Then I decide if I want to do horizontal or vertical adding. So if I do vertical, I take the first one and add the second one with its variables lined up. 16x squared plus 7, 8, 9, 10, 11, 11x. Even if I did it horizontally, I should get the same thing. So if I do a horizontal, I'm looking at, there's 5x squared, there's another x squared. Combined like terms, I get 16x squared. Then I have a 4x and a 7x, I end up with 11x. Okay? If you have questions on those, make sure you're jotting them down so we can talk about it in the morning. Okay, and the last concept is just doing the opposite. We're going to subtract instead of add. This is where it becomes trickier, because remember, when I have a subtraction in front of a parentheses, that means a -1 really is getting applied to each term inside there. So let's look at how we do this, and then we'll talk about what's the easiest way to do it and how you like it. So I want to start with this horizontal one. So I'm going to remember that when I subtract, I'm really just adding the opposite. So if I get in the habit of starting with the first, I have a third, I don't have a square, so I need to leave some space. Then I have minus m plus 9. Remember, I'm subtracting 4m squared, so I need to line it up, 4m squared, because I don't have one above. And I have m plus m minus 12. I don't change anything yet. I just line them up vertically. And then I say, well, wait a minute, I'm subtracting everything, so I'm going to change it to a plus, the opposite sign of what it was right now. And then I go back to adding. Negative 4m to the third, I don't have anything else here, so that carries down. That's just a 0 plus a negative 4, so that's negative 4m squared. Negative 1 plus a negative 1 is a negative 2m. 9 plus a positive 12 now is, what is that, 21? Is 21. Vertical will always work as long as you may remember to leave some spaces where you're missing any variable terms. So let's do horizontally. So if I'm doing horizontally, I'm going to rewrite it real quick right here. Normally you don't have to rewrite it, but I'm going to move it so I can make some marks and stuff. Plus m minus 12. So it's the same process, only we're remembering, hey, I'm really distributing a -1 through here. So I want to add, but change the sign of everything. If I do that right away, then there's no issue with messing up my signs. And then I go through and look for my stuff. So here's my highest term. So I'm going to carry that down because there's no other m to the 3. So I've handled that. Then I'm looking, my next highest is m squared. I don't have any other m squared, so I'm just going to carry that number into my process. That one's done. I have a -m and I have a -m. I have 2 negative m's. +9 and a +12 is a +21. You need to decide which method you like better. Okay? Either one works. So just be real careful with your signs because that's what does it. So let's do one more together and then we will talk about it. So we are taking this polynomial and we're subtracting the entire polynomial. There are parentheses around it, so I need to distribute that negative essentially. So let's do it vertically. X minus 3x squared plus 5x. I line them up. 7 to the third, that's the third, so that's going to be a 7x. There's a 5x squared, so that's going to be 5x squared. It's a positive 5x squared and a -12. -12 doesn't go under here. -12 goes over here because it needs to line up. This one does not have a coefficient. So we are, or a constant term at the end. We are subtracting, because it tells me I'm subtracting, which means I'm adding the opposite sign. This is going away and this becomes a plus. And then I just go straight down like I always do. So that's not there, so it's 0, so that becomes a +12, 5, this is a +5x. -3 plus a -5, they're both negative, so it stays negative, and they get added. There's a 1 hiding here. 1 plus a -7 is -6x to the third. So you should pause the video, you should practice these next 4 down below, then restart the video and check your answers. Alright, there are your answers for your practice problems. If you did not get them right, pause the video again, work them through again, see what you can figure out. If you have any questions, you should circle them, star them, do what you have to do so we can talk about them tomorrow. Alright, I'll see you in class.